Okay, so um, so no assignments due Monday because of the Memorial Day holiday. No class on Monday, and I'll have the things that are due tonight and tomorrow night graded for you, like in short order. Exam 1, cover sections P2 to P8 and 1.1 to 1.4 on Wednesday. Make sure you have a working webcam. If we can do a quick practice run here right now, guys. If you don't mind, please try turning on your webcams and see that they're working. I'll give you a quick help on how it goes. If you don't want to, you put your hand over it or something like that, if you're not in a presentable state or something. Can we give that a try, guys? Turn on our webcam. So down at the bottom of this, down at the bottom of the screen, right? There's this share video right here. Share video. So you'll push that. I don't know. I probably can't do it while I'm screen sharing, but you'll push on this share video thing. Okay, and I should be able to. Let me stop sharing my video for a moment. Samir, Trevor, you guys want to give it a shot, please? Try turning on your webcams. Anthony, you're good. Trevor, good. Samir.
Yeah, mine's not.
Oh, sorry, Anthony, we got you already. Ben, Chase. I can't see everybody at one time, but so you push on that. Let me show you again if you're having trouble. So share application screen. So you push on that icon there. Now, if it doesn't work, then what you need to do after you push on this is to take a look at this, guys. Come all the way up here to your browser bar. There's another icon here, and you have to work with the settings here. Camera, use right facing, and allow access to camera and microphone. Okay. So, like the browser, I think it pretty much automatically will block the camera. So you have to, at some point, have enabled this, right? So we need to have that working for everybody on the exam day. So I'll email the exam to you guys. We'll turn on your webcams and then work on the exam and then scan and upload to Dropbox in the usual fashion. Okay. Alrighty. So let's go back to section 1.3 and finish up our discussion there, and then section 1.4. And then on Tuesday, we will review those sections and any material that we can do after that. So we were talking about lines, okay, in 2 dimensions. Now a line has this parameter called a slope, okay, which is the change in y over the change in x between any 2 points on the line. And that slope, it never changes no matter which 2 points you pick. This ratio is always the same. The rise over the run. Rise is the difference in the y coordinates. Run is the difference in the x coordinates. Okay, so for example, like we got this line here and it's got this point and that point. The slope is -3/4. By the way, a slope from left to right goes down when it's negative slope. A slope from left to right goes up when it's a positive slope. two basic ingredients are necessary to define a line. One, you need the slope, and two, you need some point on the line. Given those two ingredients, you can get an equation of the line as follows. Now, this equation isn't unique. There's different ways of expressing this equation depending on which point A, B on the line that you use, right? I mean, the line's got infinitely many points. So, given the slope and some point on the line, if I chose a different point on the line, I'll get a different equation here. But that's okay. All right, and this is called the point-slope form of the line. Now, the point-slope form of the line is just a rewritten form of this. Y minus b over x minus a, which is rise over run. You divide both sides of this equation by x minus a, and then you just get this, slope parameter again. So writing it like this makes it a linear equation rather than a fraction, which, is, often more convenient. And this is called the point-slope form of the line. So now any point xy on the line will satisfy this equation because that slope parameter is a constant for any particular line. So find the equation of the line with slope 2 and containing the point -1, 3. All right, so slope m is equal to 2, and AB is equal to -1, 3. So you take that point-slope form of the line, y minus b is equal to mx minus a, and you just plug in those numbers. Now, be careful when you're plugging in a negative number because, these two negatives become a positive, right? So this is y minus 3, x minus -1, and that slope is 2. So this is the point-slope form for the line, okay? And if I picked a different point, I would get a different point-slope form, but that's fine. Okay, now for any other point on the line, pick some x, like x equal to 4. If you want the y coordinate that goes with that x coordinate, you plug in x equal to 4, and then you solve, and then you get y equal to 13. So this line contains -1, 3. It also contains 4, 13. If you want to pick x equal to 5 and see what the corresponding number is here, it's going to be 5, 15, actually, because the slope is 2. You can do that. A second form for the equation of a line is this, and that's called the slope-intercept form for the line. So it is y equals mx plus b. M is the slope, and b is this y-intercept. So it looks like this. Here's b, and the slope of this thing is m. So this is a negative slope that I've drawn, but that b is right there. It's the intercept of the line with the y-axis. So, for example, going back to this equation here that we had in the previous example, y minus 3 is equal to 2x plus 1. This is the equation for the line with slope 2 and passing through the point -1, 3. Put the equation into slope-intercept form and find the y-intercept and the x-intercept, and then sketch the graph of the line. So to get to y-intercept form, slope-intercept form, just solve for y. For y to get to slope-intercept form. So you have this y minus 3 is equal to 2 times x plus 1. Multiply through the 2. 2x plus 2, add 3 to each side, and you got y equals 2x plus 5. Okay, so the slope is 2, and the y-intercept is 5. Now, to find the x-intercept, so here's the xy axis, and there's the 5. To find the x-intercept, just plug in y equal to 0 and solve for x. So along the x-axis, the y-coordinate is 0. Right, so the y-coordinate is 0 along the x-axis. The x-coordinate is 0 along the y-axis. So since we're looking for the x-intercept, plug in y equal to 0 and solve. And you get x equal to negative 5/2. So now that you have the x-intercept, negative 5/2, and the y-intercept at positive 5, you can just graph those two, plot those 2 points, and then, any 2 points uniquely define a line, and there it is. Let's take another example of that. Okay, find the slope-intercept form for the line containing points, let's say 1, 1, and 3 minus 5. No, 3 minus 2. So find the slope-intercept form. Minus 3 will do. So 1, 1, and 2, yeah. Find the slope-intercept form for the line containing the points 1, 1, and 3, negative 3. Then find the x and y intercepts for the line, and then sketch a graph of the line. Okay, so first thing we need is the slope. Slope is equal to, rise over run. Okay, now the rise is the difference in the y-coordinates divided by the difference in the x-coordinates. Make sure, okay, that you keep the same order when you take difference. So we'll do minus 3 minus 1. That's the difference in the y-coordinates over 3 minus 1. Right? So I took this point first, this point second. All right, so this point first. So minus 3 minus 1, and then positive 3, positive 1. All right, so minus 3 minus 1, positive 3 minus positive 1. All right, you can do this one first and that one second, but just do the same thing on the top and bottom. Either way will be fine. Doesn't matter which is first and which is second, as long as they're first both times and second both times. So this gives us minus 4 over 2, so the slope is minus 2. All right, so now that we have the slope, we can find, and we have a point on the line, we can find the point slope form of the line. All right, so that's y minus a equals m times x minus b. And we'll use ab equal to, now you have 2 points to pick from, I'll just use the 1, 1. Use ab equal to 1, 1. You could use ab equal to 3, negative 3, doesn't matter. Okay, so I have y minus 1 is equal to minus 2 x minus 1. So this is the point slope form. And now you can take the point slope form and transform it into slope intercept form by solving for y. Solve for y, so I'll multiply through by the negative 2 minus 2x plus 2. Now add 1 to each side, so y is equal to minus 2x plus 3. So this right here is the slope intercept form. So the slope is negative 2. The y-intercept is 3. So the y-intercept is y equal to 3. And the x-intercept, plug in y equal to 0. So you have 0 is equal to minus 2x plus 3. So I'll add 2x to both sides. So I have 2x is equal to 3. So x is equal to 3/2. So I have y-intercept 3, x-intercept equal to 3/2. So now here is a picture of this graph. So 1, 2, 3, we'll say. And then 3/2 will be half of that length. So here is a picture of this line. It's like super hard to get lines nice on this tablet. It's so slippery screen. Okay, here's my x-axis. Here's my y-axis. Okay, and then of course we knew a few other points on the line. What were they? We knew the point 1, 1 is on there. And what was the other point? 3, negative 3. Right, so we also knew that 1, 1 was there, so that's about here, I guess. And 3, negative 3, well, that's going to be like over here. So now we've got these 4 points on the line. X-intercept, y-intercept, and those other 2 points. Okay, some special lines. Horizontal lines. So a horizontal line has slope 0. Right, and the equation for a horizontal line is just y equal to k, where k is the y-intercept. So for example, the line, so here's the x-axis and the y-axis, and then say like here's negative 2 on the y-axis. This is the line y equals to negative 2. So y is equal to negative 2, x is equal to anything. Alright, so this is 0, negative 2, this is like 1, negative 2, 3, negative 2, 4, negative 2, so on and so forth. Negative 1, negative 2. All right, so when you say y equals negative 2, you mean this horizontal line. Vertical line, here the slope is undefined. Slope is undefined because slope is rise over run, and the run is always 0, and you can't divide by 0. Slope is undefined, and the equation is x equal to k, where k is the x-intercept. So, for example, here would be, say, x equal to 3. So that's the line x equal to 3. So here's 3 on the x-axis right there. And this is the point, say, 1, 3, 2, 3, minus 1, 3, minus 5, 3, or, sorry, these backwards. 3, 1, 3, 2, 3, minus 1, 3, minus 5, so on and so forth. So on the line x equals 3, the x-coordinate is 3, the y-coordinate is whatever. Okay? Couple more facts about lines. Two lines are parallel. Well, parallel means, you know, the distance between them is a constant. So their slopes must always be the same. When they have the same slope. So, for example, y equals 1/2 x and y equals 1/2 x plus 1. So y equals 1/2 x, that's the line that has slope 1/2 and y-intercept equal to 0. All right, so that's the x-axis, that's the y-axis, which I still didn't get vertical. There it is. All right, so this is the line y equals 1/2 x. Now, if you want parallel line, y equals 1/2 x plus 1. Oh, it's not going to work. Hold on. This is the line that has the same slope, so that it's parallel, but the x-intercept, or y-intercept, sorry, is 1. So this is the line y equals 1/2 x plus 1. Right. By the way, when the line when there's no plus b there, that means b is 0. So y-intercept is 0. Y equals 1/2 x plus b. Or sorry, y equals 1/2 x plus 0. So 0 is the y-intercept in the first line, and 1 is the y-intercept in the second line. And those two lines are parallel because, you know, the slope is 1/2. Two lines are perpendicular. Perpendicular. When one has slope m and the other has slope minus 1 over n, right, the negative reciprocal. So slopes are negative reciprocals of each other, and otherwise when you multiply them together you get -1. m times negative 1 over m is negative 1. So, for example, y equals 1/2 x plus 1. So perpendicular meet at a square, meet at a 90-degree angle. So, for example, y equals 1/2 x plus 1, and y equals minus 2x plus 1. So, in that case, right, I've got the line here. The perpendicular line doesn't want to work sometimes. So here's that line, y equals 2x, or sorry, 1/2 x plus 1. And now the line, 1/2 x plus 1. Now the negative reciprocal of that is negative 2. All right, so, and it's going to have the same y-intercept, and they're going to meet at a 90-degree angle. So this is y equals minus 2x plus 1. And that angle there is square. Okay, so that's the basics of lines. Two different forms for the equations, point slope and slope intercept. And you can graph a line by having 2 points, in particular the y-intercept and the x-intercept. And parallel lines have the same slope. Perpendicular lines, slopes are negative reciprocals of each other. Okay, so here the slope is 1/2, and here the slope is negative 2. So the negative reciprocal of 2 is positive 1/2, or the negative reciprocal of positive 1/2 is negative 2. So just take the fraction, flip it upside down. Okay. Section 1.4 is on solving quadratic equations. So far the only equations really we're able to solve are linear ones. Okay, but now, we'll talk about how you solve a quadratic equation most generally. So, by the way, let's get our terminology straight. There's quadratic polynomial, quadratic equation, and quadratic formula. So there's 3 things that go with quadratic. Let's be careful about what we mean. So a quadratic polynomial in standard form would be something like this: ax squared plus bx plus c. Okay, it's a polynomial of degree 2. That's not an equation. That is a polynomial, which is, polynomial expression or algebraic expression, whatnot. A quadratic equation in standard form is ax squared plus bx plus c equals 0. That's an equation. Equation has a left-hand expression, a right-hand expression, and the two are equal to each other. Okay? It's an important distinction. So there's three basic methods for solving. The first method is the easiest, but it doesn't always work. Solving by factoring, and this only works if you can factor. So, for example, if you've got 2x minus x minus 1 equals 0, okay, so solve for x. In the 2x squared minus x minus 1 equals 0. So that's the quadratic equation, and you want to solve it for x in standard form. So in order to get it in standard form, you may have stuff on both sides of the equation, in which case you push it all over to the left-hand side. You add or subtract from this side and move it over here. Collect like terms, and there it is. Well, this one factors. It's 2x, x, and these both have to be 1. 1 is positive, 1 is negative, and there it is. Okay, so 2x plus 1 times x minus 1 equals 0. Well, remember, in the real number system, a times b equals 0 if and only if a is equal to 0 or b is equal to 0. So a product of two things is 0 only when one or the other is 0. Within the real numbers, there are other algebraic systems in which that's not true. You can take non-zero numbers in other algebraic systems, and their product would be 0. You actually know one, but I'm not going to get into that. So 2x plus 1 equals, so here, this means 2x plus 1 is 0, or x minus 1 equals 0. And now these are both linear, so you can solve for x. So this is 2x equals negative 1, and then you divide by 2, x equals negative 1/2. So that's one answer. And with this one, you just get x equals 1 by adding 1 to each side. So you have, in a linear equation, you only get one solution. But in a quadratic, you often get 2. Sometimes you just get 1, but you'll often get 2 solutions. So here you have x equal to 1/2, negative 1/2, and x equal to 1. Let's check that. Okay, 2 times negative 1/2 squared minus negative 1/2 minus 1 is equal to, well, negative 1/2 squared is a quarter. Minus 1/2 minus negative 1/2 is plus 1/2 minus 1. 2 times 1/4 is 1/2 plus 1/2 minus 1. Well, that's equal to 0. 1/2 plus 1/2 is 1, and then 0. And also x equal to 1. 2 times 1 squared minus 1 minus 1. Well, this is 2 minus 1 minus 1, which is 0. There it is. Okay, so if you can factor the polynomial, the quadratic polynomial in the quadratic equation, then you can solve like this. Easy peasy. Another example. What should we do? X squared minus x minus 6, right? This is x minus 3 times x plus 2 is 0. So this means x minus 3 equals 0, or x plus 2 equals 0. Add 3 to each side, and you get x equal to 3. Subtract 2 from each side, and you get x equal to minus 2. All right, so two solutions, 3 and negative 2. All right, so So that's great as long as you can factor the polynomial. If you can't factor the polynomial, there is a general solution method which involves completing the square. So a method of solution that always works, involves square roots and completing the square. Okay. So, for example, if you have something like this, if you have x squared minus 9 equals 0. Well, I mean, this you can factor it, okay? You can factor it's x minus 3 times x plus 3 equals 0. That's great, okay? So you can factor it, but let's not do that. So let's talk about how you use square roots. So what you do is you add the 9 to each side, so you get x squared equals 9. Now you take square roots of both sides. Okay, remember the square root of a number is always positive. The square root of x squared, therefore, cannot, the square root of x squared has to be positive, but x might not be positive. So the square root of x squared is the absolute value of x. Okay, but rather than writing this, we write the following. X equals, then we use this little symbol here, plus or minus 3. So the absolute value of x is 3. That means x equals 3, or x equals negative 3. Right, the square root of x squared, right, I mean like minus 3 squared, the square root of minus 3 squared, we talked about this, is 3. Right, it's the square root of 9, which is 3. Right, so when you say the square, so when you say x squared equals 9, the square root of x squared is equal to 3, which means x equals plus 3 or x equals minus 3. So this plus or minus means x equals 3 or x equals minus 3, and that's your solution there. So that's an example. Here's another example, and this one's important. X squared plus 9 equals 0. So in this case, you subtract 9 from each side, and you get x squared equals minus 9. So the square root of x squared is equal to the square root of minus 9. But you can't take the square root of a negative number. Okay, so the square root of negative 9 is not a quote-unquote real number. Okay, you can use such numbers. What you do is you call it I, 3i. So if you expand your notion of what a number is, and call the square root of negative 1 this thing called I. I don't know if you've ever encountered that. So you just declare this new number, the square root of negative 1. That's a number. Okay, we'll call it I. Then the square root of negative 9 is 3i. We're not going to do that, but people do it, and it's a very worthwhile notion of what a number is, and it's got lots of once you expand your notion of numbers and include this thing called I, which is the square root of -1, a lot of things that don't work nicely in the real numbers suddenly work nicely. So for that reason, it's a good notion. But we're not going to talk about that anyway. So quadratic equations, they don't always have solutions. They can have two solutions, one solution, or no solutions within the real numbers. So in this class, we'll just say it doesn't exist. That x squared plus 9 equal to 0 has no solutions. Okay, so that's the basic idea with square roots. And, you know, it's easy to explain when there's no middle term, when it's just x squared minus a squared. X squared minus a squared, it's easy to do. You move the a to this side, take the square root of both sides, and then x is plus or minus the thing you get on the right. All right, but it works more generally than that. As a matter of fact, it always works. So completing the square and square roots. So this method always works. And we're definitely going to have one of these on the exam. I'm going to want to see you complete this, solve a quadratic by completing the square. So one question like this on exam 1. All right, so for example, let's go back to this one. X squared minus x minus 6 equals 0. We already solved this one. We know that the solutions are 3 and -2. It factors. This one is x minus 3, x plus 2 equals 0, right? So we already know the solutions to this one. This by factoring. So this is x minus 3, x plus 2 equals 0, so x equals 3, or x equals -2. But let's do it by completing the square. So to complete the square, step 1, take that constant, push it over to the right. So I'm going to add 6 to both sides. So now I got x squared minus x equals 6. So that's step 1. Step 2, complete the square. Take the coefficient of the x, which is 1, divide it by 2, and square it. All right, so coefficient of x is 1, divide by 2 and square it, and you get a 1/4. So this is x squared minus x, and then I'm going to add a quarter on the left, and I'm going to add a quarter on the right. So we add a quarter to both sides of this equation to keep it balanced, and that's called completing the square. Now, okay, this is x minus 1/2, quantity squared. So when you add this special number here, you take the coefficient of x, divide by 2, and you square it, you get a quarter. Then this x squared minus x plus a quarter is x minus 1/2, the square root of this thing, squared. 6 plus a quarter is 25 over 4. And 6 is 24 over 4. So that's 25 over 4. By the way, something you may not have noticed, you know, among mathematical notation. This means 6 plus a quarter. What does this mean? Tell me, what does this mean? That means 6 times 1/4, right, which is 3/2. But then you say to me, well, Dr. Salati, no, that means 6 1/4. No, this is 6 1/4. But every cookbook and every, carpentry sketch uses that notation. to mean 6 plus a quarter. But in math, that's 6 times a quarter. So cookbook notation and carpentry notation, like, 1.5 feet. When I say 1.5 feet, I write that. But what I mean is 1 foot plus half a foot, right? Or 1.5 cups, or 1.5 teaspoons, or whatever the case might be. Something to be aware of. Okay. So now I have this. Now take square roots after you've completed the square. X minus 1/2 squared is square root 25 over 4. X minus 1/2 squared is absolute value, x minus 1/2. Not just x minus 1/2, but it has to be the absolute value because, x minus 1/2 might be negative. And this is 5/2. But skip the absolute value step and just write this. X minus 1/2 is positive 5/2, or x minus 1/2 is negative 5/2. Now take this constant, move it over here. So I have x is equal to positive 1/2 plus or minus 5/2. So x is equal to 1/2 plus 5/2, or x is equal to 1/2 minus 5/2. 1/2 plus 5/2 is 6/2, which is 3. 1/2 minus 5/2 is minus 4/2, which is negative 2. All right, completing the square. Let's take another example. So solve by completing the square. 4x squared plus 5x minus 8 equals 0. So you'll notice that the x squared doesn't have a 1 in front of it this time. Okay, when the x squared doesn't have a 1 in front of it, what you want to do is just divide by that. Okay, because x squared has a 4 coefficient, first divide by 4. So 4x squared, another page. Or, multiply by a quarter. I'll do it that way, actually. Maybe. So 1/4 times 4x squared plus 5x minus 8. Don't forget the parentheses there. A quarter times 0, of course, is just 0. This one is x squared plus 5/4 x minus 2. Now, right, I just have a 1 in front of the x squared. Move the 2 over to the right, so the constant's over on the right and all the x's are on the left. So I have x squared plus 5/4 x equals 2. All right, take the coefficient of x, which is 5/4, and divide it by 2, and then square it. All right, 5/4 over 2 is 5/8. Squaring it is 25 over 64. Got some fractions going on here, so it's a little more complicated, but it still works. Okay, again, take the coefficient of x, which is 5/4, divide it by 2. 5/4 divided by 2 is 5/8. Square it, give you 25 over 64. Add that to both sides. x squared plus 5/4 x plus 25 over 64 is equal to 2 plus 25 over 64. Right? This is now a perfect square. Square root of 25 over 64 is 5/8. So this is x, not minus, but plus 5/8 squared this time. Because that's a plus rather than a minus. If this was a minus, it would be minus 5/8. But because it's a plus, it's plus 5/8. And then, let's see, it's 2 over 6, so 128 plus 25, 13 plus 153 over 64. Now, now at this point, use that square root. Because I've got this squared bit on the right, I can do that square root. And it'll give me something I can work with. So this is absolute value, x plus 5/8. This right here, well, 153 is not a perfect square. Right, so it's just 153. Square root of 64 is 8, so that's fine. Right. I don't know anything about 153. Is it divisible by anything, or is it a prime number? 153. 51. 153 is 51 times 3. 51 is a prime number. No good. I can't do anything with square root 153. Again, we don't want to stick with the absolute value notation, so we just write it like that. This means x plus 5/8 is positive 153 over 8 or negative square root 153 over 8. Subtract 5/8 from each side. And so you get x equals minus 5 over 8 plus or minus square root 153 over 8. Not a nice looking solution, and that's why you couldn't factor it, is because this guy is not a perfect square. Okay, so the solutions are x equals minus 5 plus square root 153 over 8, or x is equal to plus or minus 5 minus root 153 over 8. So these are your solutions. Yeah, they're ugly, but they don't have to be pretty. They're real numbers just like any other. Okay, let's do one more. Do these examples yourself that I'm doing. Takes a few steps, but give it a go. X squared minus x minus 1 equals 0. Move the 1 over to the right. Okay, coefficient of x is 1. Divide that by 2 and square it, and you get 1/4. So I have x squared minus x plus 1/4. You always add, by the way. Okay, add 1/4 to both sides. So now this is x minus a half squared, and this is 5/4. Square root on both sides. So I have absolute value x minus a half is equal to root 5 over 2. Right? Get rid of the absolute value by writing x minus a half as positive root 5 over 2 or negative root 5 over 2. And then you add 1/2 to each side, and you have x is equal to 1/2 plus or minus root 5 over 2. So your solutions are x is equal to 1 plus root 5 over 2, or x is equal to 1 minus root 5 over 2. Does anyone know what this number's name is? That's actually a number with a name. Not as famous as pi or Euler's constant E. This number, anyone know what it's called? If I say it, you'll know it, but does anyone know? Someone must. Golden ratio. You've never heard of that? So the golden ratio is the root of this polynomial equation here. So the final, and this always works. So this completing the square method always works. The quadratic formula. So sort of doing the completing the square process in general gives you the following formula. For ax squared plus bx plus c equal to 0 yields the quadratic formula. So that's the other term that uses quadratic formula, quadratic, minus b plus or minus the square root of b squared minus 4ac over 2a. Right, so this is just a formula you can remember, or you can do the completing the square process, and that will give you your solutions. But you know, factoring is always the quickest if you can do it. So, for example, x, so back to this one, x squared minus x minus 6 equals 0. So you have a is equal to 1, b is equal to negative 1, c is equal to minus 6. So x is equal to minus b, which is 1, plus or minus square root of b squared, which is 1, minus 4ac over 2a, which is 1. So x is equal to 1 plus or minus 1 plus 24 over 2. So x is equal to 1 plus or minus the square root of 25 over 2. So x is equal to 1 plus or minus 5 over 2. So x is equal to 1 plus 5 over 2, or x is equal to 1 minus 5 over 2. This one is 3, and this one is minus 2. Okay, so one can memorize that formula if you want. I mean, I've been looking at the stupid thing for decades, so of course I've got it memorized. But it's derived by completing the square process on this in general. You divide by a, and then you have b over a, divide by 2 and square it, gives you the b squared over 4a squared, and you can kind of see those numbers floating around in there. Just do that completing the square process. But I'm going to ask you to do the completing the square process on the exam. A solution done by completing the square. As well as others. Let's take one more example of that. So solve with the quadratic formula So let's do that one we had before, the one with 153 in it. Yeah, there it is. Right, so in this one, A is equal to 4, B is equal to 5, C is equal to minus 8. So x is equal to minus b plus or minus square root of b squared minus 4ac over 2. So x is equal to minus 5 plus or minus b squared is 25. 4ac, so that's plus 4 times 4 times 8. Or, yes. Yeah. Over 16. So 4 times 8 is 256. 8, that's us 2 to the third. No, 128. Yeah. So right, so that gives you 153. So x is equal to minus 5 plus or minus square root 153 over 16. So x is equal to minus 5 plus root 153 over 16, or, oh, this is supposed to be an 8. C, A is 4. Or x is equal to minus 5 minus square root 153 over 8. Right, and those are the two solutions we had doing the completing the square process. Of course, you always get the same solutions because the solutions, don't change given the solving process. Right here, where those solutions we got by doing completing the square, and the quadratic formula, of course, leads us to the same solutions. Okay, so material for the exam Tuesday. Going to go over problems in 1.3, 1.4, and then some review. And then Wednesday we get the exam. Okay. There won't be a graded written assignment on section 1.4. There's not enough time really to do it. Okay, so we're just going to do the review of the discussion problems. So you have to do those for this section. Okay. Have a great weekend, everybody, and I'll see you on Tuesday.
I have a question for you, Doctor.
Sure.